Hi, good morning. We're going to spin up a Spark cluster and install RStudio so we can use it. So I did have a Spark cluster running. I'm going to terminate it, and then we're going to do this. All right. So we're going to go to Create Cluster. Um, you know, LI LinkedIn cluster, right? We're going to use Spark, and then I'm going to use M5 4x large, and then 4 of them. So let's look at the price. M5.4x large. And actually M5 EMR pricing. So the 4x large is about 76 cents an hour. So it's about $1 per server per hour, right? You can use a cheaper one at 19, so like 24 cents an hour. So for 4 of these for 24 cents an hour, you're spending about $1. For the sake of speed and time, I'm gonna use the bigger box. All right, so hopefully this is like 15 minutes long, and I spend $1. All right, so for there, I'm going to use my shiny key pair. That is so that I can SSH into the box, which you will also need to do. If you have Windows, you'll need to look for something called PuTTY in order to do that. So create a key pair if you haven't. Now the box is starting. Here in a second, we're going to be able to get a command that will tell us how to SSH into the box. And we're going to be going a little bit faster than the box spins up. If you want to build one of these by scratch, it is possible. I have an AMI that I can share if you'd like to just use that. I prefer doing it myself because one, you don't have the EMR charges, and two, it's a little bit flexible and you can use Ubuntu. AWS uses CentOS. Oh my goodness, come on. Taking his time. These are bigger boxes. There we go. All right. So I'm gonna take this, throw it in my terminal, make sure the key file is in whatever directory you're running this on. All right, so now we're here. First thing I'm gonna do is move this over. All right, install some stuff. So this is on the GitHub repo that I have shared with you. I'm going to add a user who is myself. You can change out your name. Pause if I'm going too fast. All right, we have new users here. All right, the next thing is we need to give that user permissions within Hadoop and Spark. It's just going to take a minute for everything to load. Once this command works, then Spark has been installed and you can move on to the next step. It's kind of annoying. I just kind of sit here and play with this. That's what we're waiting on right now, right? If you see after an in, just replace that with your username. Oh, getting closer. Okay, that works. Next command. If you're looking at this on LinkedIn today or past couple days, just run the command that's on GitHub. But if you need the newest version, go here. Why? dplyr requires HTTR, which requires the C library, so that's what we're going to install next. Okay, come on. There we go. All right. Complete. All right, and if you want to give your user sudo permissions, run that. All right, now we're going to go back to our cluster, or we're going to log into RStudio server. If you do not see, edit inbound rules. Oh, let's just go back a second because I'm going too fast. So security group is required in order to create any EC2 instance. Down here, this is your master security group. You can click on it. And then in order to actually reach the server, you need to be able to hit the port. So a port is like a window into a computer, and then the source is like who can hit it. So if you just want to be insecure, you can say all traffic anywhere. So all ports are open to anyone in the world. If you do that, you're definitely going to be able to hit the RStudio server port. I believe that's already in here, but you can put that. But if you're doing this production, then make sure you do it the right way, and I'm not going to explain that. Basically, you just want to make sure that you're limiting who can access that port from whatever IP. So we've got our IP address right here. We're going to go to port 8787, put dots, and open. Oh, okay. 18. Did I do the wrong? 224.63442. Okay. So yeah, maybe we do need to open up that port. Okay. Edit inbound rules. So, like I said, I'm going to be lazy, say all traffic anywhere, because I'm going to close it up. I delete something? Oh, must have just typed it in wrong. It's not Ubuntu. Let's trim in. Alright. So now we need to install sparklyr and dplyr. This takes freaking forever, so once you've done this, then we'll meet back up. All right, we're all done. So let's go to RStudio and grab our code. I need all this. Install their packages. Ooh, I don't need the JavaScript console. All right. So let's load our libraries and then connect to the Spark cluster. This is the Spark home within this cluster. We're going to read in this data set that I have on S3. It's the ratings data set from Movie Lens. All right, so we're going to read in that. So we're importing from S3 data into Spark. Then we're going to do a little bit of dplyr. So dense rank, I'm just going to show it real quick. So dense rank is a way of ranking groups. So here we see cylinder, right? Cylinder 4, 6, 8. These are different groups here. But the rank for those groups is 1, 2, 3. So this allows us to order our movies a little bit more cleanly. What's going on with the movie IDs is that you might have something like 1, 3, 4, 6, 10. So this is great and all, but we just for orderly sake, we would like 3 to be 2 and 4 to be 3 and 5 to be 4 and 10 to be 5, right? So something like this. All right. So, but in this particular case, we have things like, we'll have 2 movies. So that's where that dense rank comes into comes in handy, right? So, all right. All right. So we've got our data in there. We're going to dplyr that data, and then we're going to run the model. Boom. So I'm not going to go over hyperparameter tuning or anything fun like that. We're just getting the data and running it, getting some data out. So I'm going to run the model, and then I'm going to come straight down to recommend. Let's see what job's running over here. All right, model's done running. So with that model, assuming you've set your hyperparameters and you like the way that it looks, you could come down and look at a recommendation. So we're going to get the top 2 items for any given user, and then collect that data. So it's using the model to look at all of our different movies for any given user and say, hey, we think that you're going to like these top 2 movies. You could have n 20, 30, or whatever, but it just takes longer to run, so I just thought I would do n is equal to 2. All right, data. And then let's arrange. So for user 1, these are the top 2 ratings, top 2 movies. And then you have two items for all of the users. All right. So if that makes you happy, then you can go over here and hit terminate. I'm going to do one other thing. So you can actually extract the matrices used for these predictions from Spark. So in this particular case, it's in model, item factors, and user factors. So my understanding of alternating least squares is that you have a big sparse matrix of users and movies and recommendations, filling in those squares, those spaces. And what we're trying to do is approximate that big sparse matrix with a the item matrix and the user matrix. So if you were to multiply these two matrices together, you would get an approximation of the sparse matrix. These matrices are so huge that it's really hard to actually solve these problems. What is the word? A closed form solution, I suppose. So anyways, so you could take these matrices and then you could select out a user and then multiply these matrices together, but just with like a part of that matrix, right? So I'm gonna see if I can get these to download. For some reason it was taking me a while earlier. I don't know what's going on. So I'm gonna let this run here, download these matrices, and then we can do some matrix multiplication against those and take a look and see what happens. So this is data in Spark, but it's not like in our memory. So we're trying to get it down into R as a data frame. The way I think about these matrices is that, like, for all my users, I don't know, like maybe you could take these matrices out and as a user logs in, run these matrices together with that user ID and then get the top items and then load the page with those items or something. Or I don't know. Still kind of new to this stuff. You could also just use that ML recommend and then download it and put it in your database. All right, I'm not going to worry about that now. I'll make a video with a smaller matrix to kind of show that it's not really necessary for the model, you know, because you can just use ML if recommend. I'll see if I can find a faster way of collecting that data. It seems like, I mean, yes, these are big matrices, but I'm not so sure it should take that long. So anyways, I hope this was interesting. Thanks.